I'm just going to do a quick video to help you a little bit with the compound interest project. All right, so this is really just a couple application problems that deal with compound interest formulas. So the first problem is just asking you to calculate how much money you will have accumulated in an account. Okay. And it gives you a couple different formulas you use. Okay, so here's the two formulas up in the problem. Let me change to red here. Here's the two formulas that you're going to need depending upon the situation. And then your information will be different than mine. Okay. But it wants us to find out, how much money we will have accumulated, the accumulated value of an investment. So we're going to put $15,000 into an account. The account pays 4 years interest. Interest rate is 5%. And then we have these different situations, compounded semi-annually, quarterly, monthly, or continuously. Okay. So what that means is that they'll calculate interest on your money. If it's semi-annually, they'll calculate interest twice a year. So N would be 2. If it's quarterly, it'd be N equal 4. Okay. If it's monthly, it'd be N equals 12. And then continuously is like N is infinity. So you can't really plug in the number. So when it's continuously, you use the other formula. Okay. The one that looks like this. Okay. All right, so let's just try a couple of these. Part of the difficulty with this is actually entering it into your calculator correctly. So please go grab a calculator right now so you can practice that part of it with me. I'm going to do C and D, okay? So on C, we're trying to figure out how much money we'll have in our account if we compound monthly, okay? So for C, I'm going to use this formula. And there's a video you can watch to help you with these problems also that's part of from the Pearson site. Okay, so we're looking for the A. We know in my case that we had $15,000 invested. The interest rate was 5%. Now, part of the issue might be just making sure you change that to a decimal properly. 5% means 5 divided by 100. It means this, okay? And a shortcut you can do, dividing by 100 actually just moves the decimal 2 places. So 5% is going to be the same as the decimal 0.05, okay? And so what we need to do here is the R would be 0.05. The N is how many times you're going to figure out the interest on the money. You're going to do it 12 times each month. You're going to do it. And notice there's an N out here as well. And then we're going to leave our money in there for 4 years. Okay. All right. Now, when you type this into your calculator, here's where some of the problem comes in. So you can just type it in like this, 15,001 plus, you can do 0.05 divided by 12. That part's fine. You can use the little raise to the, but you can't just do this. All right. If you entered it like that, the calculator will do what you tell it. It will follow order of operations. But if you type that in like that, it doesn't have the same meaning as what you see on line 2. Because when you raise it to the 12 times 4, only this right here would only get raised to the 12th power. Okay. Then the whole thing gets multiplied by 4. So if you're going to enter it like this, you need this to be in parentheses, or better yet, just figure that out. That's 48. And instead of doing 12 times 4 right there, enter 15,000, then 1 plus 0.05 divided by 12, close the parenthesis, raised to the 48. This is the biggest problem, is not putting that 12 times 4 together in an email. Before you enter it on your calculator. Sorry, I was trying to reply to an email. Okay, so when we enter that, you're going to get a decimal. And so another issue sometimes deals with how you round things. This is what I see on my calculator screen, all the digits I see. But when it says here to round to the nearest cent, That's like dollars and cents. So it doesn't mean to round to the nearest dollar. It means to round to right there. Okay. And so what you do is you look at the number after it. And if it's less than 5, you'll just truncate that. You'll just drop those digits. And you're saying that you will have accumulated $18,313.43. Okay. And that's what you're going to put in there. Okay. And you don't put the dollar sign because it's already there. So you just put this part. So that would be the answer to C. Okay. All right. Now, when you get ready to do D, you have to use a different formula because it was continuously. So you're using the A equals PERT. So let me put it right here. Oops. Don't do like I did. That R is an exponent. Okay. Like that. Okay. And so the 15,000 goes where P was. E is a number around 3. Okay. You're going to raise it to the 5%. That's where the R goes. And then the T is the 4 years. So that goes there. Okay. And that's what you want to type in. But again, when you type in the E, and that is found above the LN button usually, E raised to the left parenthesis. And I love that it does that because it almost forces you to include the 4. The 4 and the 0.05 need to be included in there. Or like I said on the other one, or calculate 0.05 times 4 and work this out and get 0.2 and then put the 0.2 right there. Okay. Either you've got to have both of them in parentheses or you need to have worked that out. So the 0.05 times 4 is all being used as the exponent. Okay. So when you do that one, you're going to get, this one turns out to be 18,321, and then it has 04137. And so I'm trying to round to that spot. Okay. And so it turns out to be $18,321.04. Okay. So that's D. All right, let's take a look at the next problem. The next 2 problems are the reverse of that. They're ones where you actually aren't just evaluating. See, this is just an order of operations situation on here. Same here, just evaluating order of operations. But on 2 and 3, you're actually having to solve something, right? So this one dealt with okay, let me snip this. Golly. All right, man. My goodness. Getting about 100 emails right now. Okay, so this particular problem is using the compound interest formula because we're compounding the interest twice a year. So we know our N. All right, so on this one, we're going to be plugging into this formula. So you have to see where things go. So the amount invested is actually your P. The accumulated amount is your A. Annual interest rate is your R. Compounding periods is your N. And time is T, and that's what we're actually looking for now. So we're going to know everything except T, and we're going to have to solve. So the principal was 10,000. The amount invested was 10,000. Okay. Interest rate 5.25. So if you move the decimal twice, it's 0.0525. And I'll put a 0 in front just to emphasize that's really a decimal. Okay. And then that gets divided by 2 because we're going to figure the interest twice a year. And then we're going to put a 2 up here along with the T, but we don't know the T. Okay. That's the unknown. And we're trying to find out how long it takes for that to reach 21,000. Now I could have put it on the left side, over here where the A is, but I just want to know when that's equal to 21,000. And I like my unknown to be on the left. So that's why I did that. Now, what we got to do is we got to solve this. And because T is up here as a exponent, that means logarithms are going to come into play at some point. Okay. So first I need to get the exponential part by itself. So I need to get rid of that 10,000. So I'm going to divide by it. Okay, so when I do, that turns out to be 1 plus, and then the 0.0525. Be careful not to lose that 0 right after the decimal. Raised to the 2t power. And then you can divide that out. And you'll have 21 divided by 10. So that's going to be 2.1. You can just do that on your calculator also. Okay. All right. So now at this point, if you wanted to clean this up, you could, or if you wanted to leave it like that, it's okay. But at this point, I need to log both sides, and I can do either log or ln. There's no advantage. So I'm just going to log both sides. And just be careful what you write down. Don't lose any of the pieces. And that gets me to here. Okay. So do you remember how when you log both sides, you're able to bring the exponent down in front? Okay, so let's move over here. So now we'll have that 2t down in front, which is great because that makes this turn into a linear equation. And then this log thing that looks so complicated is something I can just type in. Okay, and get a value for. So it's really just a number. Okay, so 2t log of all that equals the log of 2.1. So what I'm going to do now is come in here and I'm going to divide everything I can so that the t is by itself, and this is times on both sides. Now log is not being multiplied by 1 plus. That's a function notation. That's f of something. So here we're going to divide by 2 log 1 plus 0.0525 over 2 on both sides. I know it's messy, but oops, I didn't need to write it like that. Sorry. I know it's messy, but you want to write that whole thing there underneath both sides. So 2 log 1 plus 0.0525 over 2. Okay? So this would go away, and that would go away, and I'll just have the t equaling log of 2.1 divided by 2 log 1 plus 0.0525 divided by 2. Okay. Now this one has an issue that you might mess up on if you're not careful. These horizontal fraction bars are grouping symbols. So that 2 and that log, all that, are both in that denominator. So when you type this in, if you're trying to type it in one step, when you do your divided by, you should have a parenthesis there so that all of this, and that would be a second parenthesis. So both the 2 and the log of all of that are being divided into the 2.1. So half the battle is you entering it. So right now you should pause the video and try it, and then come back and see if you get the same thing and see if you get what you're supposed to. Okay. And so I'm getting t to be about 14.3168 and keeps on going. And when I read, it says 1 decimal place, so that's here. So I would put in 14.3 years. So it's going to take about 14.3 years. Now what I could do to test it is go back to when I set it up right here and type in 10,000 parenthesis 1 plus 0.0525 divided by 2 raised to the, and then put in parenthesis the 2 times the 14.3, and it should turn out to be around 21,000. Okay, it won't be exact, but it'll be approximately that. Okay, now your numbers are going to be different, but that should give you a good idea. All right, so I'm not going to completely work out the next one, but a question came up when I was doing this in class that I thought was a good question. So this particular problem, you are actually using the other formula because it's not being compounded. Okay. Okay. And so when I'm looking at that formula here, A equals PE raised to the RT power, what you need to do is plug things in the appropriate spot. Okay. And they didn't give you an actual value for this, but you know it's double what you invested. So you just double that. That's 7,500. You just put twice that. So it'll be 2 times 7,500, which would be 15,000. Okay. So they want to know when they're going to double their money is basically the question. So your unknown is going to be here. Everything else you'll be able to plug into. And then you need to go in and log both sides, but it'll be an advantage to use ln since this is base E. Okay. So hopefully that's going to help you. I'm going to go ahead and get this posted.